Hi, I'm Hafeez again with you, and in this session we are going to take you through to the learning curve. Learning curve is part of the budgeting, which is a quantitative technique to help us in budgeting process, planning process. So let's get started. Learning curve. Before I look into the definition and other ideas of learning curve, just a little chat about learning curve. You remember many years ago when you started to type on the keyboard for the very first time? How was your performance and speed? Were we not struggling? I mean to say, we were looking at where's the letter A and then C and L and P and so on, because we were not familiar with the job. So we started by typing very slow, but we kept on going, okay, on a day-to-day basis or whenever, based upon our jobs or our own commitments or our own aptitudes. So we kept on typing day by day. And did you notice that by repeating this task again and again and again, your speed improved? On a regular basis, your speed was improving. And this is the applications of the learning curve. That as any task is repeated, we start getting better at doing the things. We feel more confident, we improve our skills, and the time taken goes down. Meaning, because of our speed improves, so the time to complete the same job reduces. This is actually the learning curve. Whenever any new skill, any new job, any new activity starts, it takes more time. But as we keep on repeating the same complex job again and again over a period of time, it starts taking less and less time because of our confidence, our improvement in skills, and our repetition. We start getting to know better and better about the jobs. Okay, this relationship is called as learning curve. So learning curve is used to estimate more accurate labor and labor related costs, because it is about the human activity that we perform jobs or tasks again and again and again, and then we get paid on the basis of this, where these may change due to employees becoming more skilled. It can be used as part of the budgeting process, but it is also useful in other areas such as target costing, life cycle costing, and decision making. So generally, learning curve can be given on its own. Learning curve question can be given on its own as well, of course. There are short multiple choice questions, okay, where examiner may not be able to link up with something, just learning curve on its own. Or maybe in longer questions in section B, okay, where there are 10 to 15 marks available with the examiner. So examiner can include other areas of the syllabus which we have done before, like target costing, life cycle accounting, decision making, pricing, etc. Okay, so now let's understand the learning curve. It is a statistical relationship which establishes the fact that labor time per unit falls as a complex task is repeated. Labor time per unit falls as a complex task is repeated because workers become more familiar or confident about the job, and as they become more familiar with the job or production process, average time reduces, average time declines at a known rate. Okay, we will talk about this known rate slightly later on. Now, this is the definition of the learning curve, which you really need to remember, okay, because this is how we apply learning curve in practice. It says, as cumulative production doubles from the first unit, the cumulative average time per unit falls by a constant percentage. So as cumulative means total. As total production or output doubles from the first unit, the cumulative average time per unit falls by a constant percentage. Let's understand this with the help of this little example. Example is this. For example, we are provided this, that first unit takes 100 hours. Okay, I'm just assuming. First unit takes 100 hours. And we are provided that the efficiency level of the workers is at 80%. Okay, right? Or learning curve, learning rate is 80%. Learning rate is 80%. First unit takes 100 hours and the learning rate is 80%. 80% means is this, that if worker will produce the first unit, worker will take full 100 hours, for example. But as the worker will get better at doing the things by producing the first unit, the next unit he would already be familiar with the first unit. So the second unit will take less time. So for example, our HR experts have observed the people, and our HR experts tell us, supervisors, HR supervisors, they tell us that second unit should take 20% less time than the first unit because people are familiar with the job now. So we can say, if this sort of example is available, we are simply trying to say is this, that first unit takes 100 hours, so second unit should take 80% of the time of the first unit, which is 80 hours. But remember the definition. Definition says, as cumulative production doubles from the first unit, meaning to say is this, as cumulative production doubles from the first unit, when only first unit was produced, then doubling is 1 to 2, 2 to 4, and 4 to 8, and it goes on. When the cumulative or total production doubles from the first unit. So when first unit is produced, it's only 1, total production is 1. But this total production goes up from 1 to 2. So when 2 in total were produced, and then 2 to 4 doubles from the first unit. So this is the doubling effect. When cumulative production doubles from the first unit, average time per unit falls at a constant percentage. So if next column is for the average time, if this column is for the average time, can we say that first unit will take 100 hours? Okay. First unit will take 100 hours, so average time of one unit will also be 100 hours. Meaning to say is this, when we produced one unit, it took 100 hours. So can we say 1 unit multiplied by 100 hours, the cumulative or total time comes to 100 hours? Cumulative or total time comes to 100 hours? Is it okay? So if total time is 100 hours, average time will also be 100 hours because it's the very first unit. Now let's see the doubling effect. When the first unit doubles into 2, when units increase like this, 1 to 2, average time per unit falls at a constant percentage. Average time per unit falls at a constant percentage, meaning 100 times by 80%. Okay, average time goes down to 80 hours. Okay, when 2 units were produced, average time per unit falls at a constant percentage. So 80 is the average time when 2 units were produced. So can I say multiplied by 2, total time will be 160 hours? And 160 divided by 2 units is 80 hours average time. Let's do another jump, doubling. When 2 to 4 units were produced, average time per unit falls at a constant percentage. So 80% of the previous level's time comes to 64 hours. So average time per unit is 64 when 4 units were produced. So can I say total time will be 4 times by 64, which will be 256 hours, and that keeps on going. So what we are trying to say is this: as the cumulative production doubles from the first unit, average time per unit falls at a constant percentage. You really need to understand this bit. Average time. Average time is not the actual time. For example, if somebody passed one paper with 50 marks and another paper with 60 marks, can I say average will be 50 plus 60 divided by 2, okay, which is 55. Now, can I define 55 marks as the actual marks somebody received from ACCA? And you will be saying, no, I received 50 marks from ACCA in one paper and 60 marks from another paper. That was the actual marks. 55 is only an average grade. An average is not actual results. So when I'm saying 80 hours is the average time, this is not actual time per unit. This is average time per unit. When 2 units were produced, average time was 80. And if you look at 55 marks, can I say if 55 is the average of 50 and 60, one of the papers has lower marks than 55 and another paper has higher marks than 55. Exactly like this, here I am defining this 80. When average time was 80 hours when 2 units were produced, one of the 2 units took more than 80 hours, 100 hours, because first unit took 100 hours. And another second unit took less than the 80 hours. 80 is the average. So one unit took more than 80 hours, more than the average. Another unit took less than the 80 hours. Okay, at the moment we don't know. We will show you how actual time will be calculated. Okay, actual expected time will be calculated. But average, an understanding of average is in the middle of 2 extremes. If average is 55, in one paper less than average, in another paper more than average. Likewise, 80 hours is the average time and one unit of the 2 has taken more than 100, more than 80, and another unit of the 2 has taken less than 80. Okay, this is the understanding of the definition of the learning curve. Now we are provided with a formula of the learning curve in the exam formula sheet, and the geometric formula is written in this way, which is y equals to ax to the power b. Let's understand what is this formula and how does it work. Okay, it is to establish the learning curve. In this formula, this whole formula will be explained to you exactly. I have copied and pasted from the ACCA past exam paper. Okay, so this is actually the formula you will see in the formula sheet, just like this. It says y equals to cumulative average time per unit to produce x number of units. Okay, so y simply tells us cumulative average time per unit. Okay, just remember this part. It's better if you remember this part. Y represents average time per unit. So if I go back to my little example, okay, you can call this is actually the values of y. 100 hours, 80 hours, 64 hours, which was the average time. These are the values of y. Okay. Now you would appreciate why formula is important. What if examiner keeps on doing this doubling impact? Okay, an examiner says we are applying learning curve when 5,000 units were produced. Can you carry on with this table to 5,000 units? I mean, yes, at home or on the spreadsheets we can, but in exam situation it will take ages to do this doubling effect from 1 to 2, 2 to 4, 4 to 8, and keep going all the way to 5,000 units, right? So therefore we have developed a formula, okay, which is going to take very little time, whether the units are 500 or 5,000 or 50,000, the formula will take exactly the same little time, okay? So Y tells us average time to produce 1 unit. A reflects time to produce the first unit. When the first unit was produced, how much was the time? B is the slope of the learning curve, which is calculated as log R divided by log 2, log R or LR, okay, right? R is rate. Somewhere it's written as R, sometimes it's written as LR, learning rate. So log R or log LR divided by log 2, and LR is the rate of learning. Rate of learning will be provided, okay, but in one of the past exams, examiner had asked us to use the formula to work out the learning rate, which was not too difficult at all. It was just 2 or 3 marks. And X represents cumulative output. Okay, let me show you, before we move into this formula in more details, how learning curve diagram looks like. Examiners never mention, they may not ask us to develop this diagram, but it's better to understand how it works. So this is the learning curve diagram, whereby on the x-axis we plot number of units, okay, or you can call them cumulative units, and on the y-axis we can plot time per unit. But remember the definition of learning curve, average time per unit. Okay, so in the formula these two x's are used. This is x, which represents cumulative units, total units, and this is y, which reflects average time per unit. Okay, and the learning curve line is like this. Learning curve is called curve. Curve is like this. Okay, remember it cannot be like this. Why it cannot be like this? Because if it is a straight linear line, it will touch x-axis one day. And if it touches x-axis one day, it is simply exhibiting that this unit, when these units will be produced, time taken will be 0. And I don't think any task takes 0 time or 0 second. Every task, okay, easier or harder, takes some time. Okay, therefore the curve is like this. Okay, the slope or gradient is represented by b, and this b can be calculated by the formula shown in there, which is log of learning rate. Learning rate is always given, divided by log 2, which is available on your calculators. Okay, now here is the understanding. Now using this formula we can calculate value of y, okay, which tells us average time. A number of things can be developed by using this formula. Number one, we can calculate average time. How, on average, how long does it take to produce 1 unit? Okay. Number two, we can calculate total time, because if we are planning or budgeting for total number of units, we can calculate total time as well. All we need to do is y multiplied by x gives us the total time. Okay. Number three, we can also use this formula to find out specific or actual time of a specific unit. Sometimes examiners ask us, calculate the time for the 250th unit. They are not asking us average time of 250 units, but a specific actual time of 250th number of unit. 250th is 1 unit. What will be the time taken by that unit if the time is falling at a constant rate? Okay, so a number of things can be developed, which we are going to see a moment later. Here are some of the general applications of the learning curve. It helps us to set realistic labor standards. So the idea is simply this, that with the help of learning curve, because our human resource experts or supervisors keep on observing the teams of employees or workers, and they find out that what should be the realistic labor standard we should set when we plan our future. Meaning we need to tell our staff that based upon your learning experiences, based upon the past trends, okay, as you start the job, it should take this time. And as you keep on repeating the job again and again and again, it should start taking less and less time. So bearing in mind, by the end of day, we want time to be reduced. So it helps us to set certain benchmarks, standards, or directions. It also helps to find out number of people we need for our work. All we need is to know that how many units do we have to produce? What will be the total time taken to produce these units? What are the number of hours available in a day or in a shift, etc. And by looking at the information, we can find out manpower needs. I mean, I can give you one example, okay? Examiner never asked us, it's not part of the syllabus, it's the application, okay? For example, if I say we've received a job number 201, for example, from a client. We received a job of 201 from a client, and this job says we need to produce 200 units. Based upon learning curve formula or something, we found out average time will be 2 hours. I'm just assuming simple figures so you can understand how manpower needs or number of people can be calculated. Average time is 2 hours. Our shift policy is 8 hours every day, because people get tired afterwards, so shift is regular 8 hours per day. And the client has given us a deadline to deliver this in 5 working days. The client has asked us to finish the job and hand over the job in 5 working days. So maximum time available to us is 5 days. Now here is, if this information is available to us, can I say 200 units will take 400 hours? 200 times by 2 will take 400 hours. Okay, 400 hours, and there are 8 hours a day available. Okay, so if I divide this by 8 hours, it gives me 50. We need 50 people. Okay, if it's 50 days. Meaning, if let's suppose there is only one employee will work for 50 days to finish this job. But the deadline is only 5 days. So what if I divide 50 days by 5 days of deadline? Will I not get 10 staff? That if I have 10 people and they work on a regular basis 8 hours a day, over 5 days they would finish this job. As simple as that. Is that okay? If I have 10 staff, okay, and if they work for 8 hours every day, they can finish the job. Okay, 200 units will take 400 hours. Okay, 400 hours divided by 8 hours a day is shift, and that works out 50 days we need. But if the deadline is 5 days only, we need more people, and we can find out the manpower requirements as well. Okay, by looking at the numbers more carefully. Formulating budgets, we will see how learning curve will help us in preparing the budgets. It's all about future planning. Calculation of incentive rates in bonus wages, meaning if any employee is performing better than the learning rate, okay, we can reward them any bonuses, any extra payment or any appreciation, etc. It also helps us to set delivery dates as well. Okay, Pricing for successive units, meaning to say, if we have a job with a regular client and we know that the first job will take more time, and then successive jobs from the same client will start taking less and less and less time, and as the jobs are taking less time, we can even improve our pricing or costing. We can actually offer promotional prices to these regular clients, that if you will give us the order of 10 units, price will be this much, but if you will give us an order of 50 units, price will be slightly low, because we know that labor and labor associated costs will reduce. Okay, now let's do a little practice about learning curve, and then we will have a look at the limitations. Okay, it's better to look at some practice question and then we look at the limitations, because we will find limitations from the information. Okay, so better to learn from practice. Then I will come back to the limitations of the learning curve. Here is an example. Okay, BG has recently developed a new product. The nature of their work is repetitive and it is useful for there to be 80% learning curve effect when a new product is developed. The time taken for the first unit was 22 minutes. So you can be given time in minutes or in hours. Doesn't really make any difference. The formula doesn't know whether it's minutes or hours. Assuming that an 80% learning effect applies, requirement number 1, calculate average time per unit when 4 units were produced. Number 2, calculate total time for 4 units. And number 3, calculate time for the 4th unit. Okay, so there are 3 requirements. By using the formula, okay, formula is y equals to ax to the power b. Now from the information we are given a time for the first unit, we are given x, which is the total order size, which is 4 number of units, but we are not provided full value or full information about b. So first of all, let's learn how b is calculated. Okay, because now we have got, in the past b value was always given, but because of the introduction of new exam structure, when there are multiple choice short questions as well as long questions, so it makes it a very likely 2-mark question when examiner will ask you, by giving information, calculate b value. B value is this: log LR, which is learning rate, divided by log 2. Okay, it's always the base of log 10. Okay, but your calculators are already set for this. You just need to apply the formula. So what we do is, we know learning rate is given 80%. So what we do is log 80%, and on the calculators we insert in decimals the percentages, 0.8, divided by log 2. Now there are different calculators different people might be using who are listening to me now. Okay, some people use such calculators when you insert log functions, soon as you punch in the log key, a bracket opens. If the bracket opens, make sure close the bracket as well. So it will become like this: you entered log and then a bracket opens, then insert 0.8 and then close the bracket, and then log 2, if bracket opens, make sure insert number 2 inside and then divide it by and then close the bracket, and that gives us the value of b. So let me try in this way, which is, my calculator is slightly different. Okay, I'm looking at the log, there is the log function, divided by log 2. So 0.8, log of 0.8 divided by log 2, and the answer comes in negative. Okay, b equals to minus 0.3219, something like this. Okay, generally we should round off b value up to minimum 4 decimals, otherwise examiner tells us. Okay, if no instructions provided, at least 4 digits must be there to get better answers, more accurate answers. So negative sign simply reflects time reduction. As the production is increasing, time per unit is decreasing. Okay, now let's apply this formula to our example BG. Requirement number 1 was calculate the average time. And remember, y is average time per unit. So y equals to A is time for the first unit, which is 22 minutes, multiplied this by x, which is 4 number of units, total units. X is cumulative or total units in the order. Okay, or actually remember, x simply reflects, if I take you back to the formula, in reality, this x is cumulative output up to which learning curve works. Meaning x is those number of units up to which learning can work, meaning time reduction is possible. And after the x value, there is no more learning. Okay, there is no more learning. And when there is no more learning, and if I take you back into the graph, okay, for example, here is the stage where there is no more learning. Okay, and after this point, a steady state occurs. Steady state means from this red unit, which is x, okay, from this unit, any subsequent units will take a constant rate of time. Soon as production will reach at this x number of units, learning curve will stop, that no more time reduction is possible, because of course we can't reduce the time to minimum, okay, to 0. So then learning curve becomes flat. No more learning is possible. So all subsequent units take the same time as this x unit has taken. So if this unit takes 1 hour, we are assuming all extra units, all subsequent units will also take 1 hour per unit. Is it okay? So this is the understanding you need to remember. So let's go back in there. 4 is the cumulative output, and raised to the power minus 0.3219, which is the value of B. So y equals to, now let's pick up the calculator again, 4 raised to the power minus 0.3219 negative, and then times by 22, I get 14.0805 minutes. Please remember to round off value of y to at least 4 digits or 4 decimals, because sometimes examiners create questions when rounding off up to 2 digits doesn't help. So better to be on the safe side. For value of y, anything else is fine. For value of y, round off to 4 digits. You will get more accurate answers. So what we are saying is average time per unit was approximately 14.0805 minutes per unit when 4 units were produced. Average time. Okay. So can I say, for example, well, actually it's the next requirement. I don't need to say anything specially here. Number 2, remember requirement number 2 was calculate the total time for 4 units. Okay, so here is the total time for 4 units. So if average time is 14.0805 minutes, total time equals to 4 multiplied by 14.0805, which equals to approximately 56.32. minutes. That on average, if 1 unit takes 14.08 minutes, 4 units will take 56 minutes. Is it okay? Exactly like this. If I take you back to my silly example, if somebody has got 50 marks in one paper and 60 marks in another paper, can I say total marks will be 110? Total marks will be 110, and 110 divided by two papers, average marks are 55. If average marks are 55 and there are two papers, 55 times by 2, doesn't it give us again 110 total marks? Exactly the same idea is applied here. If average time was 14 minutes approximately, total time will be times by 4 units. Now here is more interesting stuff. In the requirement 3, we are asked to calculate actual time taken by 4th unit. They are not asking us to calculate time taken by 4 units, but they are asking us when we produced unit number 1, unit number 2, unit number 3 and unit number 4. When the 4th unit was produced, how long it took to produce the 4th unit alone. Okay, now this is the way we apply the formula for the time of a specific unit, okay, which is this. There are 3 steps. Let me write down and then we will look into the calculation as well, which is very simple. Step number 1 is apply formula twice, which is y equals to ax to the power b twice. And how do you apply this twice? First time you consider x equals to total number of units, meaning when 4th unit was produced, total units were 4. When x, because x represents cumulative or total units. So when 4 units were produced, this is the value of y or average time, okay? Once you applied this, now the second time, very simple, okay? Second time when you apply, subtract 1 from the 4. What was the previous unit? Before 4 units, how many units were produced before 4 units? And you're saying 4 minus 1 or previous from 4 will be 3 units. Okay, so we will apply this always like this, once taking into account x as the total number of units like 4 and then 1 previous unit, which is 4 minus 1 is 3rd. Okay, if examiner says cumulative units or x equals to 100, and what will be the time to produce 100th unit? All you need to do is first formula x equals to 100 and in the second formula x equals to 99. So always look at the previous unit. Okay, step number 2, so you will get 2 values of y here, one for 4 and one for 3. Number 2, calculate total time for 4 units and 3 units. So it's all literally half of minute steps. And thirdly, total time of 4 units minus total time of 3 units will give us time of 4th unit. That will give us time of the 4th unit. Okay, reason being, when 3 units were produced, then we put the next unit and that was the 4th unit. So if somehow we know how long does it take to produce total of 4 and total of 3, the gap between 4 and 3 is only 1 unit. And which is that unit? 4th unit, because after 3rd unit, the next unit put into the production was the 4th unit. So time gap between 3 and 4 units will give us the time of the 4th unit. Okay, now we have done much work already. For example, we have calculated the average time when X was 4, and that is 14.0805. We have already also calculated total time of 4 units as well. We just have to apply formula one more time, okay, which is y equals to ax to the power b. So I'm doing this requirement number 3, okay. So when x equals to 4, then y equals to 14.0805, I think. Okay, this is applying formula once. Now the second time we will apply this formula when x equals to 3, 1 unit before, which becomes y equals to 22 minutes times by 3 raised to the power 0.3219, and here we get value of y when x was 3. So 3 raised to the power 0.3219 negative times by 22 gives us 15.4468 approximately minutes per unit. So this is applying formula twice. Once this formula has been done twice, then second step is we calculate total time. So for 4 units, total time will be 4 into 14.0805, which was calculated already, 56.32 minutes approximately. And now we are calculating total time for 3 units. So 3 units times by 15.4468 minutes, which gives us 3 into 15.4468, 46.34. Okay, and the last step is the time gap between total of 4 units and total of 3 units will give us the time to make the 4th unit, okay, and that comes approximately 10 minutes, or you can make it more specific answer as 9.98 minutes. So 4th unit will take approximately 9.98 or rounded off 10 minutes. This is how we apply the formula. Now let's apply this learning curve application into a larger interest, looking at a section B type question, okay, when we are given a number of things to deal with it. Okay, let's have a look at the information. Limitation PLC commenced the manufacture and sale of a new product in the 4th quarter of 2012. In order to facilitate the budgeting process for quarters 1 and 2 of the next year, which is 2013, the following information has been collected. So they were doing the budgeting process for the next 2 quarters. Forecast production or sales, which is in batches of product, is as follows. So in quarter number 4, which is the very first quarter, 30 batches, that's the forecast. In quarter number 1, which is the second quarter in a continuous order, another 45 will be made. And then in the third quarter, which becomes quarter number 2 of 2013, another 45 batches will be added. So can I say, based upon information provided, when the quarter number 4 will end, X will equal to 30, because in total cumulative number of batches were 30 when the quarter number 4 finished. So cumulative production of quarter 4 is 30. Okay. When the first quarter ended, we had produced another 45. So can we say X equals to 75, including the batches of quarter number 4? So when quarter number 1 ended, In total, we had produced 75 batches, which includes the effect of quarter number 4 and quarter number 1. And why did I add 30 and 45 for the learning curve? I think you got the answer. I was waiting, you need to think about. I think you got the answer. Reason being, learning curve is a continuous or consistent process. Meaning to say, if I am working in quarter number 4, whatever the learning I will gain in quarter number 4, do you think I will forget that learning when the new quarter number 1 will start? Meaning, if I was learning to drive in quarter number 4, soon as quarter number 1 will start, I would forget how I was driving. If I was typing every day in quarter number 4, soon as quarter number 1 will start, would I forget how I was typing? No, learning is a consistent and continuous process. So whenever the value of x is taken, it takes into account the previous learning, because we don't go crazy. We still remember things what we have been doing in the past. Okay, so it is a continuous process. As the quarter number 2 has ended, we would add another 45 batches, and now x becomes 120. Meaning to say, if we are applying the formula for the quarter number 4, we will consider x equals to 30. So y equals to ax to the power b, and x will be 30. But if we are doing the budgeting for quarter number 1, x will be considered as 75. Okay, and then when we will finish off quarter number 2, x will be taken as 120. By the way, that gives me another understanding which I have just done in a small question. Remember BG 5 minutes ago? That gives me an idea. What if I take the difference between 75 and 30? Doesn't it give me 45 batches? Yes, 45 batches of quarter number 1. And what if I take, in a slightly different way, what if I calculate total time of 30 batches and total time of 75 batches, and I take the difference between total time of 75 and total time of 30, wouldn't I get total time of 45 batches made in quarter number 1? Exactly the way I was doing it in here as well. Okay, which is the time gap between 4 units and 3 units. I don't need to know whether 3 units were made in quarter number 1 and 4 units were made in quarter number 2. It's a consistent, continuous process. Okay, right? Let's keep understanding the information. Okay, it is estimated that direct labor is subject to the learning curve effect of 90%. So this time learning effect is 90%. So soon as it's given, you can develop value of B. Remember how B is developed? B is log 0.9 divided by log 2, and you will be able to get some negative answer on your calculator. We will see in a minute. The labor cost of batch number 1 of quarter number 4. Now quarter number 4 was the very first quarter. So batch number 1 will be very first batch. So the labor cost of batch number 1 of quarter number 4 was $600 at $5 per hour. Labor rate was $5 per hour. By the way, from this information, can I not develop A, which is $600 divided by rate $5 per hour, which gives me 120 hours to produce the first batch? And that is the value of A, time to produce the first unit or time to produce the first batch. Okay, the labor output rates from the commencement of the production process of the product after adjusting for the learning effects are as follows. So they have given us some details. Okay, right? For example, for a minute, what if I hide this information? That I'm not interested in this information. I want to show you, I promise I will show you. For a minute, if I don't look at this information, because this information is mostly not given, well, not mostly, always not given, only in one paper it was given. In most of 100% cases, we have to develop this table ourselves, or we have to develop some of this table ourselves, not all of this, but some of it. Let's learn how to develop some numbers, and we will then compare with the information provided. So for the moment, please don't look at this table, okay? It will be a better learning. We will develop from scratch numbers in this table, okay? All time will be paid for at $5 per hour. So labor rate is $5 per hour. Variable overhead is estimated at 150% of direct labor cost during 2013, meaning soon as we know the labor cost, budget for variable overhead can be calculated as multiplying labor cost by 150%. All units produced will be sold in quarter of production at $1,200 per batch, which is a selling price. Now, requirement A is a very little requirement to warm up. Calculate the labor hour requirement for the second batch. Remember, the first batch, which is A, takes 120 hours, and requirement A is calculate the labor hours for the second batch. Okay, so here is our example limitation PLC. Okay, requirement A is time or hours for the second batch. Okay, second, not two batches, but time for specific batch number 2. So because it's second unit, it's not too difficult to find out. Okay, it's not too difficult to find out. What we can do is like this, as we had done it before. Let's be consistent. If they ask us to calculate time for a specific unit, we will, number one, we will apply the formula twice, y equals to ax to the power b. Okay, first taking into account x as 2 units or 2 batches, and then x taking into account 1 batch. Is that okay? 1 previous, so 2 minus 1 is 1. Okay, well, if it's 1, it's not going to make any difference. Anyway, idea is this. Y equals to A is the time for the first batch, 120 hours, multiplied by X, which is 2, and B value, okay, let's develop the B value by using the calculator, which is log 0.9 divided by log 2, and that comes to, my calculator shows me 0.15200, so on. So I can consider this B is negative 0.1520, okay, because there is another 0 afterwards, so I can just round off up to here, okay. And now I get something like 0.1520 negative into 120, and I get y equals to 108 hours. When 2 units were produced, average time per unit was 108 hours. This is the step number 1. Okay. If you fancy, you can try formula for x equals to 1 as well, but no need. Why no need? When 1 unit was produced only, first unit has taken 120 hours. First unit takes 120 hours, or first batch takes 120 hours. So second step was calculate total time for 2 units times by 108, which is 216 hours. So whatever the average time is, multiply that by x value, which is 2 number of units, total units times by average time. And total time for the first unit was given in the question, which is 120 hours. And this time gap between 2 units and 1 unit will give us time for the second unit or second batch, 96 hours. So second batch, wherever I am using the word unit, okay, please excuse me for this, okay, because generally the word unit comes in mind first, okay, but it works both ways, whether it's units or batches. So second batch will take 96 hours, okay. Now let's have a look at the next more exciting requirement. Prepare a budget for each of the quarters number 1 and 2 of 2013, showing the contribution earned from the product, show all relevant workings, okay. Now you just need to remind me what is contribution. Oh, that's brilliant. Contribution is simply sales minus variable cost. So what we are looking at here, budget for quarter number 1 and quarter number 2 of 2013, showing the contribution, okay. So if I split that into 2 columns, that here are the numbers of quarter number 1, here are the numbers of quarter number 2, okay. Starting with sales, okay, simple things first. We are given here selling price of each batch is $1,200 per batch, and we are given in quarter number 1 and 2 how many batches we are going to sell. So 45 batches in quarter 1, also 45 batches in quarter number 2. So $1,200 selling price times by 45 batches, that's our budgeted revenue, okay. So 1,200 into 45, budgeted revenue is $54,000. Okay, so revenue remains the same because volume is same, selling price is the same. Now here is less variable costs. Sales less variable costs equals to the contribution. Now we read the whole data so far and there were only 2 variable costs given. One was the labor cost and second one was variable overheads. Okay, and that equals to the contribution. So sales less variable costs equals to the contribution. Okay, they purposely haven't given us the materials. It makes question even more longer. So that's why, otherwise materials can be easily calculated if it's given. Okay, now let's do the labor cost calculation with the help of a working. Okay, because more calculations will be made. So let's do this with the help of a working number 1, labor cost calculation. Okay, let me do it for quarter number 1 first. Labor cost of quarter number 1, 2013. Now can I say quarter number 1 comes after the quarter number 4 has ended? So can I say step number 1, apply the formula twice, okay. Y equals to ax to the power b when x equals to 75 and then x equals to 30, and the gap between 75 and 30 will give me time for 45 batches produced in quarter number 1. Okay, so let's do this. Y equals to A is time for the first batch, 120 hours, times by x, which is 75, raised to the power 0.1520 and negative. So y comes to 75 raised to the power 0.1520 negative into 120, which is 62.25. Okay, or we can take it further, hours per batch. Okay, so when X was 75, Y was 62.25. Okay, let's do this formula again. When X equals to 30, so Y equals to 120 times by 30 raised to the power 0.1520 negative, and here we get Y. 30 to the power 0.1520 negative into 120, it comes to 71.56. Meaning to say, when X was 30 batches, Y was, average time was 71.56 hours. Okay, before I move further, I just wanted to show you something. What if I now show you this table? The first column of the table shows total batches produced, and remember, total output, cumulative output, is represented by X in the formula. And the next column is overall or cumulative average time per batch, and average time is represented by Y. So when X was 30, Y was 71.56, and when X was 75, Y was 62.25, and I think I have just got exactly the same figures by using the formula. Okay, I didn't want to show the table first because this was only one paper when all numbers were given, but we had to do a little bit more repetition of this formula. That's why I took slightly longer way, so at least we can learn things better by reinforcing the knowledge again and again and again. Okay, so that's the value of Y's at two levels of X's. Now second step, you remember, we calculate total time or cumulative time. Total or cumulative time. So total time for 75 batches will be 75 times by 62.25 hours, and the total time for 30 batches will be 30 times by 71.56 hours. So if we multiply average time by the total units or total batches, we get cumulative or total time. So 75 times 62.25, we get something like 4669 approximate hours. And the second one is 30 into 7156, we get 2147. And the gap between 75 and 30 batches is the 45 batches in quarter number 1 of 2013, which will take approximately 2,522 hours. So in quarter number 1, 45 batches will be produced, which will take approximately 2,522 hours. And that can help us to develop the budgeted labor cost of quarter number 1, which is going to be 2,522 hours times by $5, and that comes to, remember, labor rate was $5 per hour, so 12,610 within the brackets, because we will take it away from revenue. Remember, variable overheads were 150% of the labor cost. So variable overheads 150% times by the labor cost, which is 18,915. Now the difference between revenue and variable costs equals to the contribution, which comes to $22,475. Okay, so expected contribution is $22,475. I suppose you can apply the same principle to quarter number 2 as well. So I can leave this bit as your homework. Okay, all you need to do is this. I can tell you some guidelines for the quarter number 2. All you would need to do would be, can I say in quarter number 2, which is this. In quarter number 2, if I just remove this, 45 batches were produced in a total of 120 batches, meaning in quarter number 1 we produced 30, then in the second 45, and then in the third another 45. So when all batches were produced, cumulative output, total output was 120. Okay, so now can we say like this, that for quarter number 2 of 2013, labor cost of 45 batches these 45 batches would be produced after 75 batches have already been made by yesterday, meaning till the last quarter. So when the last quarter ended, we had already produced 75 batches, and then we put another 45 batches in this quarter. Okay, so it will be the difference between total time for 120 batches and total time for 75 batches. And this gap between 120 and 75 will reflect 45 batches, and that will reflect number of hours to produce 45 batches. Okay, so exactly the same steps which I have shown you here, you've got to apply on these lines. Apply the formula twice and then calculate total time, and then the difference between total time of 120 and 75 will give you precisely the time of 45 batches. Is that okay? So a little bit of practice from your end. Here is the requirement C. Requirement C is Limitation PLC wishes to prepare a quotation for 12 batches of the product to be produced at the start of quarter number 3 of 2013, meaning to say when these 3 quarters have ended, then the next quarter would be quarter number 3 of 2013, when they received an order of another 12 batches. Requirement is calculate the cost of labor and labor related costs, meaning variable overheads incurred as a result of the additional batches produced. So I can give you the guidelines again and you can try this. Okay, can I say when so this is for quarter number 3 of 2013 for additional 12 batches. But remember, just before quarter number 3, 120 batches had already been made, and then we will put another 12 batches. So can I say the labor cost or labor hours will be the difference between total time of 132 batches and total time of 120 batches, because after 120 batches were already been finished, we added another 12 batches in this quarter, making up a total X value or cumulative output of 132 batches. So this time gap would tell us specific time for the 12 batches to be produced in quarter number 3 of 2013. And then you can calculate labor cost, and then you can multiply that by 150% to arrive at the variable overheads. Okay, so a little bit of task at your end to see if the ideas are working. Okay, let's have a look at some of the limitations of the learning curve. So maybe for 2-3 marks, if it comes to discuss, at least you are aware of. Of course, it's little bit mathematical method, but a number of issues relating to learning curve. Number one, it is only applicable to those industries which heavily rely upon labor or manual activities, manual techniques. So if any organization or any manufacturing process runs over the machines, computers, robots, well, the robots never get tired, machines never get tired, it's the human. Robots never learn, machines never learn, it's the humans. Okay, so number one, it is based upon labor intensive environment, and learning curve can only apply when it's repetitive jobs. It's not like unit number 1 was to produce umbrellas and unit number 2 was to produce chairs. Two are two completely different products. There is no learning. If the job is repetitive, the same units being produced again and again and again, then learning curve applies. It assumes that employees are motivated to learn, meaning to say that this is not just a formula 80% or 70%. Employees also put their efforts into application of learning curve. And if employee is not feeling very well, employee is not motivated inside, that you can develop any scientific method, employee will be slow. Okay, it assumes that there is a stable labor mix with negligible turnover, meaning it works fairly well in those industries where the people work for a longer time. Okay, there is a lower labor turnover, but in certain industries people keep on coming and being replaced. In those industries, there may not be an established learning curve because all the time different people are joining the team, and then learning curve goes back to zero. Difficulty in determining the learning curve effect accurately. Okay, idea is because if I, for example, in large factory, when there are 500 people working at the same time, how can we say that learning curve of 80% applies to everybody or learning curve of 90% applies to everybody? Because out of 500 people, everybody is differently motivated. Everybody has different morale. Everybody has different physical strengths. Everybody has different mental strengths. Okay, so we work out on average that this 80% reflects overall team, but not everybody individually. Otherwise, it is so almost impossible to look into the learning curve individually, okay, when the organizations are large. So especially in the teamwork, okay, it is difficult to determine accurate learning curve. It's also difficult in determining the level of production where the curve will be flat and no further learning takes place. So remember the steady state when the curve becomes flat. It's also difficult because for everybody this flat rate will occur at a different level of production. Some people may not learn any further after 100 units. Some people may not learn any further after 110 units. Some, again, for everybody is different because we are talking about labor related issues, and labor related issues come from the human issues. So as everybody is different, it could be a completely different rate, it could be a completely different steady state, okay, or it could be a completely different learning curve percentage. Okay, so that was something about learning curve. Make sure, please try to do practice as much as you can on this topic, because sometimes it becomes complicated when we don't revise the formulas or the steps which I have mentioned in here. So from your study textbook, read it well, okay, watch this video again. Pre-recorded videos are available as well. From the revision kit, try to do 1 or 2 practice questions, okay, and then you know how to get back to us. Mail my tutor, you will come back to us. I'll be waiting for your feedback, and stay in touch. All the very best. Take care and goodbye.